Okay, to finish up this section, we'll just do a couple more examples. And we'll start off with number 7, which says, which angle is smallest? We've got 1, 2, 3, 4, 5, 6 angles labeled with variables. Use the scaling inequality and the SAS inequality, or the hinge theorem. Well, this is pretty easy. Notice that, let's do the easy triangle here first, where we have it's an equilateral triangle. Each side is length 6. That tells us that A equals B equals C. It's an equilateral triangle. So A, B, and C, those angles all have the same measure. Well, in the other one, what do we know about D and E? D has an opposite side that's only 5.9. E has an opposite angle of 6, that's greater. So angle E is going to be bigger than angle D. D is less than E. And E is going to be equal to, let's see, E, opposite is 6, F, let's see. Yeah, E and F are equal. This is not equilateral, but it's an isosceles. Since this length is the same as this, those two are equal. And D is smaller than either E or F because its opposite side is. And, we can also compare them. D is less than A. Because why? Well, D has these two segments, 6 and 6, with an opposite side of 5.9. A has 6 and 6 as its segment sides, and its opposite side is 6. So D is less than all of those. So it turns out that the angle opposite the side 5.9, D, is the smallest angle. All right, let's do our last example, number 8. This seems to be similar to a previous problem we did, at least the shape is similar. Given that M is the midpoint of BC, all right, let me just say that I'll put a notch there and a notch there to indicate that. That's the midpoint. So this segment and this segment are the same length. And X is equal to AM. So X, and X is also here, so that length is equal to this one, which means it's the midpoint also of this segment. All we need to do is show that X is bounded between 2 and 33. So let's notice, we saw this before. Triangle AMB is congruent to triangle EMC because of side, angle, side. All right, so that tells us that Y is equal to the length of segment CE. Let's see, CE, and that is going to be 31. Why is that? It's because this side corresponds with this side in the two congruent triangles. Therefore, corresponding parts of congruent figures are congruent. So this is also 31. Now let's look at AM. AM is less than, okay, here we're going to use the median inequality. This triangle, this is a median of the triangle. So A, this distance is going to be less than 1/2 of this plus this. So I'll write it first as 1/2 of AB plus AC. That's exactly the median inequality. Now let's substitute in numbers. That means that X is less than 1/2 of, what is AB? AB is 31 plus AC. AC is 35. And what does that tell us? That gives us that x is less than, all right, the middle of those two be 33. Half of 66 is 33. Okay, so we're halfway done. We did this part. X is less than 33. Now we need to show that x is bigger than 2. So AC is less than AE plus EC. So let's look at this. AC is less than AE plus EC. That's a triangle inequality. This side is got to be less than this one plus that one. Triangle inequality. All right, so now let's substitute numbers in that we know anyways. So AC is 35. AE, what's AE? Well, we can rewrite that with x, 2x, 1x, 2x, 2x, and then we've got plus EC, and that's 31. Now I think we just need to solve for x, and we should be done. So that tells us that 2x is greater than, if I subtract 31 from 35, I get 4. And that implies that x is bigger than 2. So if we combine these two together, we get x is between 2 and 33.